This is our last module for module 3, module 3.6, and we are talking about sketching graphs and comparing functions. So let's look at our learning target. I can sketch graphs of functions. So whenever I am sketching a graph, there are certain key features to look at. Okay, so here's a graph, and you can sketch the graph of a function using its key features, knowing the domain, the range, intercepts, lines of symmetry. Okay, so we should know the symmetry, the end behavior, the extrema of a function, as well as the intervals where the function is increasing, decreasing, positive, or negative. All this provides a clear idea of what the graph of the function looks like. So let's look at this graph that I have just drawn out, and we're going to label the graph to identify its key features. So let's look at the extrema first. Where is the relative maximum? So here, up here, this is where we have the relative maximum. This is the relative maximum. Okay, let's look at where do we have our relative minimum. So if I look at this graph here, this is where my relative minimum is. This is where my relative minimum is. Where is my graph increasing? So it's increasing here. This one here, this is increasing. And then what's happening here? This is decreasing. So this is decreasing. And then once again, what do I see on this side? It is again increasing. It's again increasing. So this is what we've got to first identify. We've got to label the graph or identify its key features, and then we can sketch the graph of a function. So let me take you to a question on my whiteboard, and let's look at this. So let's look at this question, the first example, and we are sketching the graph of a linear function. So cycling. In 2015, Christoph Strasser set a new 24-hour cycling record by riding 556 miles in a 24-hour period. The distance he rode over the 24 hours can be represented by a function. Sketch a graph that shows the distance traveled, y, as a function of time, x. Once again, time is x and the distance traveled is going to be y. So if I am looking at this, let's look at what we have. Okay, let's look at what we have. So for the y-intercept, we can see that no distance traveled when he has ridden for 0 hours. All right, and so the point represents 0 hours ridden and 0 miles traveled. So this is going to be graphed on the coordinate plane, which is at the origin. And since we're talking about distance and time, we are only going to use which quadrant? We're only going to use quadrant 1. Okay, so 0, 0 is the ordered pair, which is at the origin. And then we have the linear or non-linear. So the graph of the function is going to be linear because over, the more time that he is traveling, the distance is increasing. So yes, it's going to be a linear function. Positive because for time greater than 0. Okay, again, it's increasing for time greater than 0. The graph is a straight line that is positive and increasing for all hours ridden. So look at this now. Here is the example of the graph. Let's look at the end behavior. As the number of hours he has ridden increases, the number of miles he has traveled increases. So once again, as x increases, y increases. So here is the graph. And this is what I was talking about. You have the 0, 0 over here, and then as the time in hours is increasing, the distance that he's traveling, that is also increasing. So as x increases, y increases. And yes, this is a linear function. So now we are going to sketch the graph of a symmetric function. So let's look at this question. And then we'll look at what are the key features that have been provided for us in order for us to sketch the graph. So whether a person's happiness can be affected by temperature. Sketch a nonlinear graph that shows the happiness of a person y as a function of temperature x. Interpret the key features. Okay, so let's go look at what the key features are. But as a normal human being, you know that when it's too cold or it's too hot, we are not that happy, right? We need the correct temperature to be comfortable. So based on what key features are provided, we are going to be creating a symmetric graph in this case. So let's look at our key features that are provided. It's saying that it is positive between about 25 degree Fahrenheit and 89 degree Fahrenheit. And for temperatures less than 25 degree Fahrenheit and greater than 89 degree Fahrenheit, it's going to be negative. Then increasing for temperatures less than about 57 degrees. And then for is telling us that it's decreasing for temperatures greater than about 57 degree Fahrenheit. So it's provided us these key features, and looking at this, we are going to create a graph. Okay, so here is some more stuff that is provided. It's giving us the relative maximum. And the relative maximum, because we said it's increasing to 57 degrees and then going down after that. So at about 57 degree Fahrenheit, when a person's happiness is about 85. And a relative maximum occurs at 57 degree Fahrenheit, or x is equal to 57, and a happiness of 85, or y is equal to 85. So it's given us these key features. This is represented by the point 5785, which we can graph on the coordinate plane. So end behavior, as temperature increases or decreases, a person's happiness decreases. So looking at all these key features, let's look at what we are going to graph. And one more thing, it is symmetric, because a person's, and it's telling us this also another key feature, a person's happiness for temperatures less than 57 degree Fahrenheit is the same as the happiness for temperatures greater than 57 degree Fahrenheit. So a person is happiest when it is 57 degree Fahrenheit. As the temperature gets increasingly cold or hot, a person becomes less happy. And when the temperature is below about 25 degrees or above about 89 degree Fahrenheit, a person is unhappy, because you're going to be so uncomfortable. You're going to be either really cold or you're going to be really hot. Okay? So therefore, it's telling us that it's a symmetric graph. So these are all the key features that have been provided to us. And now let's look at the graph. And here it is. Okay? So one method for sketching a graph given key features is to first graph any given points. Okay, so remember what it said, we are happiest at 57 degrees, and it said 57 degrees and it said y was 85. So that is my relative maximum that I have graphed. Okay, and then it said that we don't want a temperature, it also told us that it is positive between what? It said it's positive between 25 and 89. So positive means it's above the x-axis. And then negative means it is below. So it told us that it is positive from 25 degrees to 89 degrees. So this is the part that it's positive. Okay, and then it said for temperatures less than 25 degrees, and so less than 25 and greater than 89 degrees, it is negative. So yeah, it's gone below the x-axis, and it's increasing for temperatures less than about 57. So this is increasing. And then it's decreasing for temperatures greater than about 57 degrees. So it has given us all these key features. And now we are just plotting this on the graph. And it's talking about a person's happiness. Then it says the person is happiest at 57 degrees. At about 57 degrees when a person's happiness is about 85. So look, it's given us that. That's the relative maximum. And then it's telling us the end behavior as temperature increases or decreases, a person's happiness decreases. All right, so it's given us all of this, and it's also given us the symmetry. A person's happiness for temperatures less than 57 degrees, okay, less than 57 degrees is the same as the happiness for temperatures greater than 57 degrees. So all these key features have been provided to us, and then we can sketch this graph. Okay, all right. Let's look at another example really quick, and I'm going to talk about the key features to sketch the graph of x as a function of y. And we're going to examine the key features and graph to identify which key features Mariana graphed correctly and incorrectly. Okay, so this is what we have, and then we're going to look at these key features. And let's see what did she graph correctly or incorrectly by looking at this one. All right, so let's look at this one, and we are looking at which of these statements or which of this was graphed correctly or not. So it's saying it's positive between x is equal to -3 and x is equal to 0, and for x greater than 2. So let's look at this. And here is my 0, -1, -2, and we have -3 here, and then we have 1 and we have 2. So positive means that it is above the x-axis. So let's look at the first one. Is it positive between x is equal to -3 and 0? So this part of the graph is above the x-axis. So yes, it is positive. And it's saying for x greater than 2. So if x greater than 2, is this line going above the x-axis? Yes. So the first statement is correct. Let's look at the second statement. Negative for x is less than -3. So less than -3, has the graph gone down? Yes, it is negative here. And then, and between x is equal to 0 and x is equal to 2. So between 0 and 2, has the graph gone below the x-axis? Yes, it has. So this is correct. So it's saying that for about x is less than -2, and between about, for about x is less than -2, and between about x is equal to 1 and x is equal to 3. So what's happening in between? It is not increasing. It's not increasing. Okay, so this is incorrect. And then it's saying decreasing for between about x is equal to -2 and x is equal to 1 and x is greater than 3. So in that case, it's going up. So therefore, this is not decreasing. So that would be incorrect. So the first two were correct, and the last two in this case were not correct. There are some more statements that were made. So let's look at this. It's talking about the intercepts of the graphs, and we are going to see if this person was correct or not. So it's saying the graph intersects the x-axis at -3, 0, 0, 0, and 2, 0. So here is my -3, 0. Here is my 0, 0. And here is my 2, 0. So is that correct? Yes. The graph intersects the x-axis at -3, 0, 0, 0, and 2, 0. So this is correct. And then it's saying that the relative minimum over here, which is the relative minimum, is at 1, -2. So this is 1, and then you go down, this is -2. So yes, this is correct. Then it is saying that the relative maximum is -2, which is 1, 2, and 4. Okay, so 1, 2, 3, 4, and 3, 2. So no, this one, no. It's saying 3, 2 over here. And that is not the relative maximum. So this is not correct. The end behavior, as x increases and decreases, the value of y decreases. And that is not correct. On the left side, as x is decreasing, what's happening here? Yeah, over here it's going down, but over here as x is increasing, the value of y is also increasing. So therefore this is not correct. Okay? All right, here's another example. We are sketching the graph of a nonlinear function. I was talking about an amusement park. The number of people in line for a roller coaster throughout the day can be modeled by a function. Use the key features to sketch a graph of the function. Then interpret the key features if x represents the time in hours since the ride opened at 10 a.m. and y represents the number of people in line. So let me give you the key features, and then we are looking at the graph also. So here we go. Here are the key features that are provided to us. And we can see that this is a nonlinear function. So it's saying that between positive is between x is equal to -5/10 and 12. So as we can see from -5/10 to 12, this is positive. That means the graph has to be above the x-axis. All right. Let's look at where is it negative. When it is less than -5/10 or greater than 12. So look, less than -5/10 or greater than 12, the graph is now below the x-axis. So yes, it is negative. So where is it increasing? For x is less than 1 4/10, okay, where it's less than 1 4/10 and between x is equal to 5 3/10 and x is equal to 9 9/10. So let's look at what they said again. So for x is less than 1 4/10. So if it's less than 1 4/10, which is here, right? So everything till here, look, it's increasing. And then between x is equal to 5 3/10, this is 5, so and 3/10, and all the way to 9 9/10, which is up there. So yes, that is where it is increasing. And where is it decreasing? For between 1 4/10, okay, and all the way down. So what is it saying? X is equal to 5 3/10. And where x is greater than 9 9/10. So it's telling me where it is decreasing. Where are the intercepts? The graph intersects the x-axis at negative 5/10 and 0 and 12 and 0. So this is the x-intercept. And then intersects the y-axis at 0, 220. So this is the y-intercept. Okay, so it's giving me all these key features. What is the relative minimum? So relative minimum, we have definitely over here, we have 5 3/10. Okay, and we have 133. So we have 5 3/10 and 133, and that is my ordered pair. So 5 3/10 and 133. So this is my relative minimum. Okay, and then let's look at the relative maximum. It is at 1 4/10 here. And what is it saying? 1 4/10 and 448. So 448. This is my relative maximum. And I have 9 9/10 and 643. So this is also my relative maximum. And what is the end behavior? As x increases or decreases, the value of y decreases. So again, as x is increasing or it is decreasing, the value of y is decreasing. So these are the features that were provided to me, and based on that, this graph has been created. Let's look at one with marine life. Okay, so it's giving me all these key features, and I am going to say these key features while I'm looking at the graph so it makes sense. So it's telling me where is positive, where is negative, where is decreasing, relative maximum, end behavior, symmetry, etc. So I'm going to say the key features, and let's see which graph it is going to be. To show the height of a dolphin above the water y as a function of time since it emerged from the water x. So let's look at these 4 graphs. I'm going to bring it closer so you can see better. Okay, so the first thing it is saying that it's positive between 0 and 8. So if I look at positive between 0 and 8, look, we have 0 to 8. This is positive because it is above the x-axis. This is not positive. The others are positive too. All right. So let's go ahead. But however, we are looking at 0 to 8. And so this is the first one that I can stare at and look at. Okay, that really makes sense. Then it's saying negative for time less than 0 seconds and greater than 8 seconds. So looking at this, immediately I can look over here. Time less than 0 seconds, this has gone below the x-axis. And for time greater than 8 seconds, this has gone below the x-axis. So now this graph is gone. This graph is not the correct one. We're looking at this one. If this one, A, is meeting all the features that I am talking about. Okay? The next thing it's saying is decreasing for time greater than 4 seconds. So look, after 4 seconds, what happened to the graph? Yes, it is going down. So it is decreasing. Then let's look at more key features, what it's saying. And the next thing this graph is mentioning is that the relative maximum is at 4 seconds. So if I look over here, is this my relative maximum? Yes, it is. Okay, so it is at 4 seconds. The end behavior. As x increases and decreases, the value of y decreases. So when x is increasing or it is decreasing, the value of y is also decreasing. Yes, that is correct. All right. And then the next thing, symmetry. The right half of the graph is the mirror image of the left half in approximately the line x is equal to 4. So if I look at x is equal to 4, the right half is symmetric to the left half. So looking at these 4 graphs, I know that my answer choice will be A based on the key features that have been provided to me. Okay? Then what can we say about the graph in this situation? So the negative x values represent the time before a dolphin emerges from the water, and negative y values represent depth below the water. And that's, when we're doing the interpretation of the graph, and that's what it means. All right? So let's talk about comparing properties of functions. All right, here's a question on tennis. Hawkeye is a computer system used in tennis to track the path of the ball. It is used as an officiating aid to locate the landing spot of a tennis ball when players challenge a call. Use the description and graph of a player's forehand and backhand shots to compare the paths of the 2 shots if y is the vertical height and x is the distance. So, let's look at this. This is the distance and this is the vertical height. Now we're talking about the forehand and we're talking about the backhand. And then we are comparing the properties of functions over here. Okay? So, let's look at this. And it's saying, during the forehand, the ball leaves the player's racket at a height of 2 8/10 feet and travels 29 feet when it reaches a height of about 10 feet. Then the height of the ball decreases until it hits the ground 58 feet from where it was hit. And then let's look at the graph of the backhand. Okay, so let's compare the two. Let's compare the 2 of them. So if I look at the forehand, where is it hitting the ground? So let's talk about the x-intercept. It's hitting the ground at 58 feet. So that means 58, 0. So in the forehand, my 58 feet is going to be my x-intercept. Okay, so this is my x-intercept. Let's look at the backhand. Where is the x-intercept here? Over here. And this is at 70. Right? So the x-intercept in the forehand is at 58 feet and in the backhand it is at 70 feet. So I'm just looking at what is written and then I am comparing it with the graph. Let's look at the y-intercept. So leaves the player's racket at a height of 2 8/10. So this one here, this is my y-intercept. Okay, this is y-intercept. So 0 and 2 8/10. That's the ordered pair. Let's look at the backhand. This is at how much? 2 5/10. So this is 0 and 2 5/10. This is my y-intercept in the backhand. We're comparing the 2. Then the extrema. So in the forehand, maximum height of 10 feet. Okay, what's happening then? When x is equal to how much? And travels 29 feet. So the maximum height is how much? It is 10 feet over here. So this is my, when my x is 29 feet, then the maximum height is 10 feet. So this is my extrema. And what about this one? When x is 35, look, what is my maximum height? my maximum height is 7 feet. So this is my extrema. Then let's look at the increasing and decreasing. So in the forehand, it increases to a height of 10 feet from x is equal to 0 to x is equal to 29. So from x is equal to 0 to x is equal to 29, it is increasing 10 feet. And then decreases from x is equal to 29 to x is equal to 58 to a height of 0 feet. So it's increasing and then it is decreasing. Let's look at this one. Increases to a height of 7 feet from x is equal to 0 to x is equal to 35, right? And then it decreases from x is equal to 35 to x is equal to 70 to a height of 0 feet. So we can look at this and we can see where it is increasing and where it is decreasing. So the x-intercept, the tennis ball travels 12 feet farther during the backhand shot, because you can see that this is how much? This is 70 and how much is that? That is 58. So this one, the backhand, it is traveling 12 feet farther during the backhand shot compared to the forehand shot. And then the y-intercepts of the two functions mean that the tennis ball is about 3/10 foot higher at the beginning of the forehand shot, because in this we have 2 5/10 and in this we have 2 8/10. So it's about 3/10 foot higher at the beginning of the forehand shot. So just looking at this, we can compare. Let's talk about the extrema. The maximum height of the tennis ball is 3 feet higher during the forehand shot, because how much is here? This is 7. And how much is here? This is 10. So that is why when I'm comparing the two, then the maximum height of the tennis ball is 3 feet higher during the forehand shot. Let's talk about the increasing and the decreasing. The height of the tennis ball increases over a shorter interval during the forehand shot, but it reaches a higher maximum height. This means that the tennis ball increases at a faster rate during the forehand compared to the backhand shot. So this is literally how we are just comparing the two. One is written out, the other one is a graph, but just by knowing the different key terms, we can easily, or the key features, we can easily compare the two. So once again, this is all module 3.6 is about. You've got to know the key features like domain, range, intercepts, symmetry, end behaviors, extrema, the intervals, where it is increasing, where it is decreasing, where is the graph positive, where is it negative. When we have all these key features provided to us, we can sketch the graph, and let's say we have the key features given to us in one form and the graph is given of another one. We can always compare the two looking at the key features that have been provided. And this concludes our module 3 on relations and functions. Have a fantastic day, everyone.